A very good morning, and this is Business Search Lab, exercise 5, and we are looking at question 2 and question 3, which were part of your assignment. So we are talking about one tail, sorry, we're talking about one sample t-test, and let's look at the question number 2 first. The mean score on standardized math skill test is known to be 50 for the entire Indian population of fourth graders, with higher scores indicating better performance. A new math skill training program was recently implemented at a local school district, and an administrator was charged with the task of evaluating whether children under the new program have performance that is different from the national average. Preferably, the performance is higher than the national average, but test for either possibility. 25 fourth graders were instructed using the new math skill program were administered the standard math exam. The exam scores for the students are provided in file exercise 5.2 SAV, and the variable is named math score. So we have to open the SPSS file and perform the appropriate analysis to answer the following questions. We have to state null and alternate hypothesis, state research question, and then are the scores on math exam for the fourth graders different from the national average? We have to test this at alpha is equal to 0.05. What is the effect size? And would you characterize the effect size as small, medium, or large? And last is write the results of the study using APA format as appropriate. So this is the question before us. Revising the question again, and if you look at the question, we are basically aware that the standardized math skill uh, uh, is you can say is 50 for the entire population of fourth graders. So that's the score, that is average score for, you can say, for students in India who are in fourth standard. And a new math skill training program has been recently implemented in one of the local schools. And there you can say we are having 25 students whose performance can either be higher or lower to the national average because of the new initiative in, you can say, training, you can say, program of maths. So the data is available in SPSS file that is given to us with the variable being named as math score. Now we have to do, you can say, first we have to state null and alternate hypothesis. In this question, the null hypothesis is there is no significant difference among the national average and students of local fourth grade students of local school having been trained with new skill in maths and their mathematics score. This means that mean sample minus mean population is equal to 0 or near to 0. Now coming to alternate, we are trying to say that the mean score of the sample population is significantly different to the national average, and we can write this as mean sample minus mean population is not equal to 0. So this is null and alternate hypothesis for us. We can write it that way. Now coming to the statement that, okay, fine, what can be the research question? The research question is there a difference in math score of fourth grader students who have taken up the new mathematics new mathematical training skills in the local school as compared to the national average for fourth grader students? So that is the research question. We can frame it this way. And now coming to, you can say, the C question, are the scores on maths exam for the fourth graders different from the national average? So we have to find it out. So what we'll do is we'll simply move to the screen, and I'm sharing, you can say, the file. So this is it, and This is the math score which we have got. So this is what the math score basically is, and we have you can say we have the variable view where the math score is the variable. Label, we can mention that maths score of students of school, where you can say the new training program on maths is being imparted. So that's there. And it doesn't matter whether it's there or not. So this is what you can say is given the SPSS file. Now we have to go for one sample t-test. So we go for analyze, we go for compare means, move to one sample t-test, and then math score is the test variable, which we are clicking here. Options, we need not do anything because alpha is 0.05, which means that confidence interval is 95%. So we'll continue with that. Test value, since you can say the national average is 50, so that is where we are looking at whether the score by students of the local school where training in mathematics is being given, to the score of that school, you can say, is either quite low or quite high as compared to national average of 50. So that is what we are checking, and therefore the test value is 50. I'll just simply click OK, and then maybe we have got the result in the output file. So I'm coming with the output file now, and there we are. So this is the output file we've got. Now we are looking at the t-test. We've got one sample t-test we've got, and if you look at, you can say math score, we had 25 students. The mean is 55.44. So that's the mean. Standard deviation is 10.73. So that is what is given to us. And if you look at, you can say the t-value is 2.534, with degree of freedom being 25 minus 1, that is n minus 1 is 24. And significance is 0.018. It means it is quite highly significant. 0.05 or below to it would mean that things are not that things are, you can say, significant. So if you can say I'll be just moving to the question because we need to see the question first. So if you look at the C part, are the scores of the maths exam for fourth grade different from the national average? We'll say yes, the scores are quite different. Because if you look at, you can say the mean value is of the sample is nearly 55.44, whereas for the, you can say, national, you can say, average is exactly 50. And if you look at the t-value, we are having for this this is, as we can see from the output file, is 2.534. And significance is 0.18, which means p is less than 0.05, and that's there. So this way you can say we know that there's a significant difference in the scores of, you can say, students who have been given the new, you can say, training on the maths for the fourth graders as compared to, you can say, the national average. Now coming to, you can say, what is the effect size and how would you characterize the effect size as small, medium or large? Now if you look at effect size for one t-test, if you look at the notes, we have seen from the notes that effect size is basically being calculated by, we have got D is equal to mean of sample minus mean of population divided by the sample standard deviation. So we have 55.44 minus 50 upon 10.73577. So that we have got. So 55.44 minus 50 is equal to 5.44 divided by 10.73 something. So roughly, I'm just, you can say, answering it. The value of, you can say, D for effect size will be nearly zero point 0.5, a little less than that, 0.5 or a little less than that. Now, if you look at, you can say, effect size and 10 of the notes, we know if D value is zero point 0.2, it is low, zero point 0.5, it is medium, and zero point 0.8 or more, it is large. Now here you can say the effect size happens to be medium because D value is nearly zero point 0.5. So that way we have answered uh, sorry, the D part of the question. Now again, looking at the last part of the question, which is here, and the E part of the question is write the results of the study using APA format as possible. So we are writing the answer, and I will be just speaking the answer, not mentioning the written part, because if you can say look at the notes, you will be easily able to do it on your own. And the answer is that um, the fourth grader students of the local school where the new training program on maths is conducted have significantly higher math score. Within brackets, you can write M is equal to 55.44, comma, standard deviation is equal to 10.73577, bracket close. Then the national average, full stop, national average, comma, T within brackets, small t, within brackets 24, that is the degree of freedom, is equal to 2.534, comma, P is less than 0.5, comma, D is equal to, D is effect size, and we have already calculated it. So it will be coming, D is equal to 0.5 or some little value, then that will come. So you can look at that value, calculate it, and do on your own. So this is the answer for question number 2. Now let's move to the final question for the of the same, you can say, exercise. Here I'm talking on question number 3 now. So question 2 we have done. So question 3 we are talking now. So I'm saying a researcher wanted to examine whether students were either in favor or opposed to a presidential candidate. So 50 students were asked to indicate which of the following statements best reflect their opinion about the candidate. So here is a question where we are trying to examine whether students are in favor or opposed to a presidential candidate. So 50 students have been asked to indicate which of the following statements best reflect their opinion about the candidate. So they have given some opinions that I strongly favor the candidate, I am somewhat in favor of the candidate, I'm neither in favor nor opposed to the candidate. So this is the statement that was there, and these are the answers you can say you have to give. So 1 means that you are strongly favoring the candidate, 5 means you are totally opposing or strongly opposing the candidate. So that's there, and we collected the response from 50 participants, and the data is provided in exercise 5.3.sav, and the variable is named score. So we are opening the file and performing the analysis. And now here we have to look one thing, that we want to examine whether students are in favor or opposed to the president candidate. Now, if a student is, you can say, scoring 1 or 2, it means they are favoring the candidate. If the student is scoring 4 or 5, it means they are not in favor of the candidate or they are opposing the candidate. 3 is neutral, whether they are not expressing their views, they are neutral, neither in favor nor against the presidential candidate. And now this, what it means basically is that if R value is, you can say, either is different from 3, and that we have to see. So here you can say the average value or the general average will be 3. So test value will be 3 here. So I suppose we are getting my point. The same thing I've already, you can say, mentioned in the hint also. First of all, we have to state the null and alternate hypothesis, state the research question. Then we have to also say, you can say, to the test, and find out whether you can say we have to find out whether you can say students are favoring or opposing the candidate, and alpha is equal to 0.05. We have to find out the effect size being low, medium, small, medium, or large, and then we have to, you can say, write the results in the APA format. Now, coming to null and altered hypothesis, we'll simply say that students, you can say, have no significant difference uh, regarding their opinion about the presidential candidate. This means that if we are talking on that, students are basically, you can say, in the neutral view. So the sample also, you can say, has got a neutral view as compared to, you can say, the test score which we are looking at to be 3. So this is what the null hypothesis is. The alternate is that the average is not equal to 3. It's quite high to 3. So maybe you can say high or low to 3. So this basically means that the students, 50 students who have been, you can say, asked the question, their responses are not 3. They are either above 3 or below 3. And that is a significant difference they're having. So we can frame the null and altered hypothesis on that basis. If you are asking for the research question for the data, now research question can be that there's a significant difference. Is there a significant difference? I repeat, is there a significant difference in opinion of students either favoring or opposing the presidential candidate, vis-a-vis they're having neutral opinion, which is the general perception. So that's what the, you can say, research question can be. Now coming to, you can say, talking of or talking about C, D, and E. These are 3, you can say, left you can say parts to question 3 that we'll be talking. And for that, what we'll do is we'll simply shift to the new share where I'll open exercise 3 for you. So this is it. We are sharing exercise 3 now. So this exercise 3 is before us, and I suppose the exercise is available before us. So we have got the data view. We have got the variable view. So this is a variable with us. Data view, we have got data of, you can say, 50 respondents. That's there. And the variable view is there. So we have got score, and this is the score the students have given, whether they are opposing or, you can say, favoring the student. So the values are already given to us. So though I have not mentioned the values, that's not correct. But we can simply have the values, you can say, coming up here. Like I'll say 1, strongly favored, 2, favored, 3, neither favored nor opposed. This is what we are saying, neither favored nor opposed. 4, opposed. And 5th I'm talking about is strongly opposed. So this is what we are saying. And then I'm saying okay, and the scale is given to us. So that is given to us. Even if we do not write values, it doesn't matter much. But I'm just telling you that it's always good to have, you can say, values put up. Even label should be mentioned. And this I can request you all to do on your own, that here you can put the label that this is the scores or respondent scores on opposing or what do you call it, either on favoring or opposing the presidential candidate. So that's done for us. Now I'm coming with the analysis part, how we are going to do one sample t-test. So we go for analyze, we go for compare means, we go for one sample t-test, click on it, and here you are. You have got the data set, the score is the variable. So we'll push it to the test score. Options, since alpha is equal to 0.05, which means that the coefficient interval percentage we are taking is 95%. So we'll be continuing with that. and test value 3 I'm taking. This I've already talked on that, and then I'll simply click on OK, and I'll be, you can say, moving you to the new share of output. So we are looking at the output file, and this is what the output we have got. So we can look at the output. So we have got the n is 50, mean is 3.16, and standard deviation is 1.056. Now, if you look at the t value is 1.071. Degree of freedom is 49 because we have got 50 students. 50 minus 1, n minus 1 is 49. And if you look at the significance, significance is 0.290. So that is what the answer is. Now, if you look at the answer, the opinion of students is again, you can say, quite near to being, you can say, neutral, and therefore we are accepting the null hypothesis. As you can say, the t value comes to 1.071 with a significance of p is greater than 0.5, and because of that reason we can say we are accepting the null hypothesis and not accepting the alternate hypothesis. Now, talking about the effect size is equal to, is also, you can say, given by symbol d. D is small d, I mean. So small d is equal to mean of sample minus mean of population upon standard deviation. So mean of sample is 3.01 minus 3, or 3.16 rather. The mean of sample is 3.16 minus 3.00 upon 1.05676. So if you look at the answer is coming quite low. The answer is in some very small decimals, and d value, you can say, will come very small. Please calculate it, and definitely you can say it is less than even 0.2. So if d is less than 0.2, it means the effect size is small. If it is, you can say, near to 50.50, effect size is medium, and if it is 0.8 or more, it is large. So we know where you can see the effect sizes. So this question D is also done. Now coming to the last part of the question, where we have to talk about the APA format for writing the result. We can write the sample of respondents selected for the study on how they perceive the, you can say, the presidential candidate. The results are similar to the notion that to the general, you can say, image that people have or students have neutral opinion. And the sample also suggests the same, with m is equal to 3.16 and standard deviation of 1.05676. So that's there, and we are accepting the null hypothesis at t value of 1.071, and the degree of freedom being, you can say, 49, and p is greater than 0.05, comma. You can also mention the value of d, so that we have already calculated. We know it's somewhat even less than 0.2. So you can please mention it as you have already calculated it in D part of the question 3. So that is where the answer is. I suppose I've been able to make you understand this topic of one sample t-test. We have done the notes. We have taken up the example of the notes. We have done question 1 of the exercise. Question 2 and question 3 have also been done by you, and I suppose we now have learned what one sample t-test is. Requesting you all to submit your assignments also in case you have not submitted it by now. So do submit the assignments. Thank you then. Thank you.